Hello and welcome to the course of Engineering Hydrology. First of all, we need to know what is hydrology and one overview about the hydrology. Hydrology, or rather engineering hydrology, is basically the study of water, any sort of hydrology. If we are considering hydrology term, that refers to the study of water. So either you are finding out the water cycle, the amount of water present in a particular area, any sort of study regarding those things can be considered as engineering hydrology. But why we need to study hydrology is basically to find out what is the amount of water we are having for a particular area, right? So suppose there is a city beside which, obviously for the people of the city, we need water, and water is the one of the major resources we need for the daily uses, for the agricultural purpose. We need water, right? So first of all, we need to know what is the amount of water available to us. To do so, we need to see what is the amount of rainfall occurring at a particular place, what is the inflow or outflow of water from that particular area. Those things we need to understand, right? So to find out those things, to find out the datas, or to find out what is the amount of water available, whether we need to construct any sort of hydraulic structure or not, what should be the amount of the catchment area to supply sufficient amount of water to the city, we need to study this subject, engineering hydrology. First of all, what is coming into this hydrology is to study the hydrologic cycle, and to exactly know what are the terms they are related to the hydrologic cycle. More or less, we have already learned something about the hydrologic cycle, that is, from the large ocean body, there will be evaporation, then obviously there will be cloud formation, and after the cloud formation, when it cools down, there will be rainfall, any sort of rainfall or snowfall or something. So the form of water, any form of water, will be falling towards the earth surface, reaching to the earth surface, and obviously it will flow eventually to the ocean again, and this completes the hydrologic cycle. But whenever we are trying to see some different terms, or we are trying to study the engineering hydrology, we need to know some different terms, the engineering terms associated to this hydrologic cycle. So we are having ocean, so the initial step is the same, that is the evaporation from the ocean. So this will be the zero part or initial stage, evaporation from the ocean. Nextly, cloud formation is there. Then obviously after cooling down of those clouds, raindrop evaporation, raindrop will be there, or rainfall will be there. Any sort of rainfall will be there. Nextly, we are having this raindrop evaporation. Right. So basically, what happens? This is the one, right? So while falling the rainfall, right? While falling the droplets of the rainfall, before reaching the earth's surface, it may evaporate, and again evaporated. Obviously, this. So this will be one sort of evaporation, that is called raindrop evaporation. Nextly, we are having number 2, that is interception. Interception will be considered as that amount of water which will not reach the earth's surface. It will be interrupted by some sort of structures, like maybe tree, maybe buildings or something, and from that, before it reaches the earth's surface, it will again evaporate. It will be again evaporated. Clear? Next, this is done, this is done, this is done. Okay. Next, we are having transpiration. Transpiration already we have learned in in the school level, that transpiration is the process by which the tree plants, from the leaf of the tree plants, the water is evaporated. So this will be the transpiration. Nextly, we are having evaporation from the land. So after reaching of that raindrops to the earth's surface, from the land itself it may evaporated. So this will be called the evaporation from the land. Nextly, we are having evaporation from the water bodies. Now, evaporation from the water bodies means obviously we will have some sort of small water bodies like ponds or streamlines, rivers, etc. So from those water bodies, the water may again be evaporated, and that will be the evaporation from the water bodies. Next, if we are having surface runoff. So what happens actually after you, obviously you have already familiar to this phenomenon, that is whenever this raindrop comes or touches the earth's surface, obviously the whole portion of the, if the intensity of the rainfall is higher, then you can see that of the total amount of rainfall will not be soaked instantly by the, I am using the term soaked right now as because we don't know the exact term right now. So soaked by the earth's surface. So what will happen? The excess amount of water will run through the surface of the earth, right? And obviously water will flow from the higher elevation to the lower elevation, and eventually it will meet the stream, any sort of river or some, first of all drain, then river or something, then to the, from the river it will go back to the ocean. So this will be called as the surface runoff. Nextly, we are having the infiltration, and that is this part, infiltration. That is the amount of water which is actually infiltrating through the soil, through the earth surface, beneath the earth surface. That is the amount of that is the amount of water which is actually soaked by the soil, right? Then obviously those amount of water which is actually infiltrated through the soil surface, it will create, or it will meet to the groundwater. It will create to the meet to the or it will meet the groundwater. It will create, or it will raise the groundwater level because of that. Nextly, we are having lastly, and obviously from this groundwater level, some portion of the water may again run through the soil surface, and it may meet the streamline, that is the rivers, and that will be called again, that is also runoff. Any sort of water which is actually meeting the river and getting out of your catchment area, that amount will be called the runoff. If it is flowing through or on the earth surface, that will be the surface runoff, and if it is flowing through the soil, then it will be called subsurface runoff, which is not here, but obviously we will see in the runoff chapter. Next, we are having the deep percolation. Now the deep percolation is some portion of the water basically percolates the hard strata. That amount of the water will be called the deep percolation. That phenomenon will be called as the deep percolation. Now those are the phenomena which I have already told you. Next, we are having catchment area. What is that catchment area? Basically, catchment area is nothing but an imaginary area which will be having one stream or outlet, right? In general, this catchment area is a basin-like structure which will be having one outlet. So the area of land draining into a stream or water course at a given location is known as the catchment area. So obviously, if it is a basin-like structure, so the elevation of the outer of this catchment area will be higher than this will be the lowest one, that is the streamline. So whenever there will be rainfall, the runoff will be through these small streamlines, and these small streamlines will meet to the larger streamline, and eventually it will get out from the catchment area. Okay. Now if we try to see what will be the water budget equation, then we can easily say that mass inflow minus mass outflow will be the change in the storage. So if you're in your catchment area, if you are having any sort of depression, so there will be some sort of storage of water, and suppose certain amount of water is coming into your catchment area and some amount of water is going out from your catchment area. So the subtraction between the incoming and outgoing will be the change in the mass storage of in your catchment area. So it may be in the depression, it may be underground, or whatever it is. Clear? So if we try to see that equation, that will look like this one, that is P will minus R minus G minus E minus T will be equals to delta S, where delta S is nothing but the change in storage, P is the incoming of water, that is mainly due to the precipitation. And what is precipitation? I will be giving you the definition. Precipitation, right now you can consider precipitation as the rainfall, right? R is the surface runoff. I have already told you what is the surface runoff. G is the net groundwater flow out of the catchment. E is the evaporation, the amount of water which is actually being evaporated. T is the transpiration. So basically runoff, surface runoff, subsurface runoff, evaporation, transpiration, those are the losses. If you consider the change in storage, those will be the losses with respect to the change in storage. So in simplifying this one, that storage, what are the type of storage there can be? There can be three type of storages. I have already told you that there can be several type of storage in the last slide. That surface water storage can be there. Water in the storage as soil moisture can be there. So if your soil is holding some sort of water, that is also storage in your catchment area. Water in storage as groundwater. So if some portion of the water is infiltrated and it is meeting to the groundwater surface, obviously in your particular catchment area, that should be considered as the storage. And if there is any sort of change, there may be increase, there may be decrease of water, that will be called as the change in storage. But if we see the equation with respect to the rainfall runoff relationship, then the equation will look like this one, where R will be equals to P minus L. What is R? R is nothing but the runoff. P is what? P is again nothing but the incoming of water, precipitation. L is nothing but the losses. Now in this case, losses are losses with respect to the runoff. In the last class we have seen that the losses, in the portion of losses we have seen the runoff part as well, whenever we are considering the change in storage. Here we are considering the rain runoff, right? So with respect to the runoff, what are the losses there can be? Obviously the other losses will be there, and with that the change in storage will act like a loss with respect to the runoff, right? So what are the losses there can be? So infiltration can be there, right, causing addition of soil moisture and groundwater storage. Evaporation can be there, transpiration can be there, and surface storage can be there. Now you can see this surface storage over there, and some portion of the infiltration which is actually making the groundwater storage. So water storages are now considered as the losses, as because we are considering the relationship between the rainfall and runoff. Okay. Those are the some global water budgets are there. In this slide we can see that the average annual precipitation is about globally is about 86 centimeter, right, out of which 77% falls in the ocean and 23% falls in the land, right. Evaporation, including the transpiration by plants, so we are considering evaporation and transpiration together, accounts 16%, and 7% of the global precipitation returns to the sea. Clear? If we see the Indian budget, then some specific data we can see there. There are some specific data as well. That is, average annual rainfall in India is 1194 millimeter. This is average annual rainfall. So there are 130 days on which rainfall is received in India. So basically 130 rainy days are there. Now what is rainy days? We have all eventually sometime hear about this term, rainy day, rainy day. So what is rainy day? Rainy day is nothing but a particular day where the precipitation will be more than 4 millimeter. That will be considered as rainy day. So 130 days are there. Now if the area of India is 329 million hectare, then multiplying the depth of the precipitation with the area, we can find out what is the volume. Now here I should say something, that is the unit of precipitation or rainfall we generally define as a depth. You can always see or always hear from the news that this millimeter or this centimeter amount of precipitation rainfall was there today. So the unit of precipitation is millimeter or centimeter. That is the depth. Why? As because if we consider any sort of catchment area, the area will be known to us. Now if we simply find out the depth of the precipitation, multiplying this area, we can get the volume of water directly. So if this is the area, we can find out what is the volume of rainfall. So almost you can see 392 million hectometer is the amount of water, almost 400 million hectometer. This is the amount of water India getting precipitation, out of which 70 million hectometer lost to the atmosphere as evaporation. About 115 million hectometer flows as a surface runoff. This is the amount which is actually flowing as a surface runoff through the India. About 215 million hectometer infiltrates into the ground surface. So out of 400, 70 million hectometer is generally a loss due to the evaporation. 215 million hectometer which is actually being infiltrated inside the ground or earth surface. 115 million hectometer is the total amount of water which are available as a surface runoff, right? So this is the amount, this is the amount which is actually available. Now in India, 20 million hectometer of water is brought by the water bodies whose catchment areas outside the India. So this is the inflow. This is the inflow from the outside of India. Also 45 million hectometer is generally it is the amount of water which is we can get in non-rainy day, and what will be the which amount of water actually we get in the non-rainy day, actually which is actually infiltrated inside the ground surface, and it is being the groundwater. Then I have already told you in the hydrologic cycle that some portion of the groundwater it will take time, obviously, as because it is flowing through the soil, it may come out in the river. I have already told you the subsurface runoff. So about 45 million hectometer we generally get in non-rainy day as that is the groundwater. So totally how much, what is the amount? This one was the available runoff. This is actually inlet inflow in the India, and this is the amount which are actually getting in non-rainy day. So total this plus this plus this, that is 180 million hectometer is the amount of water which is actually available. Thus out of 400 million hectometer, this was the total amount of precipitation. India has only this one, right? This is about the introductory part of enjoying hydrology, hydrologic cycle, catchment area, the equation, and the budget, global budget and India's budget. Thank you.